Well, good morning. Well, good morning. I appreciate you coming to this virtual training. You've signed up for it. You're going to receive training on stream crossing. We're going to talk about planning, design, and construction of typical stream crossings. My name is Drew Zelli. I'm the environmental specialist for Wisconsin Department of Ag, Trade and Consumer Protection. I've been doing this for quite a few years. I currently work Northeast Wisconsin, where I provide technical assistance to various land conservation departments all over Northeast Wisconsin. What's nice is I see a big list of the folks out here, and I see a lot of experience out here, and this should be a good presentation. I'm specifically going to talk about culvert crossing, or open channel flow crossings, and then we're going to shift over and I'm going to turn it over to my coworker Travis Buckley, who's the area engineer for Northeast, and he'll follow up after me. But again, one of the things I want to mention before I get into this, the list of attendees, you folks have got a lot of experience. I know a lot of you have been around for a long time, and some of you are brand new. So I really encourage you to question me. Not too hard of questions, but some questions. But more importantly, I really would like you to share your experiences. This practice that we're doing, the stream crossing practice, it's a pretty common practice. It probably used all over the state of Wisconsin. I've seen a lot of the stuff that you do. I've had the honor to work on practices with you, and you do things a little bit different in each area. So please chime in with your experiences. What I'm going to present to you is the way I was taught and the way I do it. And everybody's got their little nuances in there. I see my coworker Pete is on here. I've known Pete since 1986. And he's taught me a lot of different things. So there's a lot of experience out here. So I realize this is virtual training, but if you know me, I like to do things more face to face. So this would be definite training that I would do face to face, but I can't. All right. So all right. Let me invent. Well, for some reason, I can't advance. Okay. What we're going to talk about today is we're going to talk about open flow stream crossings. In other words, trapezoidal sections, parabolic sections, and then we're going to talk about culverts and then culverts evaluation. Again, like I stated before, I'm going to talk about the open flow crossings. What are we talking about when we look at it? This is a classic photo. This is in Outagamie County. This is one that was done last year. Yeah, it's just a kind of a mess, but this is a classic photo of a stream crossing and a crossing through a grass waterway. You can see in the forefront, you've got a creek. Yeah, we beat it a little bit to get all the excavation done, but we've got a point where the landowner's got to cross from one side of the creek to the other. And what we're doing here is we're basically building a nice firm foundation, and we're getting across without doing minimal damage. Then if you look behind that bulldozer, you'll see a small gravel pad, and we've got a perfect example of a grass waterway crossing. In other words, the landowner is not going to cross that grass waterway multiple points. He says, or he or she says, hey, I'm going to cross it at a defined place. So we provide that for him. This is another crossing. This is a simple one. And again, crossings are simple. This is a crossing in Fond du Lac County where we're simply crossing a diversion. This, during construction, so it's a little muddied up. But crossings are simple best management practices to address the resource concern of getting from one point to the other, whether it's animals or whether it's equipment. So you have to have a fundamental knowledge of this, because when you're doing other larger BMPs, grass waterways, terraces, diversions, stream bank protection, at some point in time, you're going to want to cross and get to the other side. And that's why crossings are handy. They're beneficial. They're good resource concern to address. But more importantly, they're usually another component of another system. For example, here, this is an old slide picture, but I like it. This is a really nice grass waterway. You got a grass waterway going down the channel. It's actually working, stable. It's not falling apart. To get across it, the landowner has a couple options. They can drive across the grass waterway, lift their equipment, or they can say, hey, I'm going to cross in one spot. So you've got a nice crossing. Yeah, that's that perpendicular line of gravel across that crossing. That's the advantage of stream crossing. So I encourage you to listen to what I have to say. This is not an in-depth design course. I only got 45 minutes, but there's a lot of resources out there, and you have a lot of resources right within your department just by looking at the list of folks. There's a lot of folks out here who design more crossings than I have. But it's a practice that you should know. Every up and coming technician should be able to design these open flow type practices. So what are we doing? Well, we're referring specifically to NRCS Conservation Practice 578 stream crossing. Okay. One of the things I have to remind you, and I encourage you to do, is read the standard. And I know that sounds really basic, but I read the standard and I read the standard and I read the standard. And when I design a practice, I read the standard to make sure I read it. When I'm reviewing your designs, I read the standard. I read the standard until I'm blue in the face, because there's always stuff to pick up in it. One of the things I personally try not to do is memorize standards, because they change. Their standards are going to change every 2 years. We tweak things, we add things, we subtract things. You know, as conditions change, we might modify the standard. You know, back in the day, we had 2 standards for manure pits. Now we've got 1. And so again, I cannot emphasize the fact that when you're working on these practices, the standard is there. They're fairly robust standards. They're well thought out. And I cannot emphasize enough, read the standard. So the big thing here is in the 578 standard, it'll have a statement like in every other standard. It'll say condition where practice applies. And this will say, hey, if you're going to do this type of practice, this is where it works. So this is from the standard. You'll see I'll paraphrase a lot from the standard in my presentation. So again, the default is always read the standard. But where does this practice apply? In an intermittent or perennial water course stream exist, right? It can be used for grass waterways, for animal equipment use, but basically it's when I want to cross that point, I want to cross that grass waterway, I want to cross that diversion, I want to cross an intermittent stream or perennial water course, right? I need to have controlled access from one side of the stream to the other, and that will eliminate or reduce environmental degradation. It also applies where soils, geology, fluvial geomorphology, and topography are suitable for construction of stream crossings. There's some places that are good for stream crossings, and there's some places that are not, and we'll see that. The logic behind this practice is this: instead of crossing the stream or the grass waterway in multiple points and allow multiple access and creating multiple, miniature resource concerns, let's limit our resource concern to one point. We're going to protect it as much as we possibly can. We're going to get whatever needs to cross it through that point as fast and as economically and as safely as possible. That's kind of the point of it. We're going to focus a little bit on planning, then we're going to get into design, and then we're going to talk a little bit about construction, right? And it's not just going to be all PowerPoint presentation. I will let you know I have a lot of photos, and we're going to do some discussion. So again, please chime in either via the chat room, or if you want to unmute yourself, I'm all for that too. Big thing with location considerations: locate the stream crossing where the stream bed is stable. It can be made stable. One of the things you don't want to do is put a stream crossing, and the first time the landowner drives through that, they get stuck. That just undoes everything you did. So you have to do an evaluation whether or not that stream bank is stable, or whether it can be made stable. And what I mean by stable, can I add stone to it? Can I add a geotextile to it? Can I manipulate it in some way, shape, or form that when I drive through it or the animals walk through it, I've got that resource concern protected? That's where a lot of what you're going to have, especially in this practice, you're going to have a lot of best professional judgment. You're going to have to make those evaluations by physically taking a look at it. You want to avoid placing the crossings where the channel grade or alignment changes abruptly. Excess seepage or instability is evident. You have to look not just at the crossing site, but what's going on upstream from it and what's going downstream from it. You don't want to place that crossing where it's going to be unstable, because the creek itself might be unstable. The creek or the waterway might be in unstable condition. You don't want to put a crossing right before we go into a corner on a creek, for example, because that's where high tractive stress is going to be. So you have to look at it in terms of geomorphologic placement. Preferably, you're putting it on a straight section and minimizing impacts. Right. Also, don't do it too many crossings out there. Landowner might want to cross in multiple different points. Try to mitigate how many crossings you're going to have and make those as robust as possible. Adjust traffic patterns accordingly and minimize it. crossing a creek by itself is a resource concern. We're trying to mitigate that by putting some type of protection on it. Okay. Make sure the crossing is properly placed. You'll see some photos where it's not, and that'll be self-explanatory. And then make sure the approaches to the stream crossings are blended with the existing site topography. Crossings are great. You get yourself across the creek, but how you physically get to them, that might be a whole nother matter. And you might actually transition from a crossing into an access road. So you'll go into the access road standard, and you'll see that in a couple of these photos. All right. Other considerations, you want to know what the landowner is going to use it for. Am I going to run cattle over it, or am I going to run combine equipment? I had a question yesterday. They're going to run combine equipment. How high does it have to be with large equipment, small equipment? What you have for existing soils, you have to do that on almost every practice. It's called foundation investigations. You want to look at what you got, make a determination whether the foundation is soft or firm. And you can do that by sticking your boot in there. You step in it. If it feels firm, it's firm. If it feels soft, it's soft. Those are, it sounds simplistic, but you have to physically go out and look at it and maybe get your feet wet a little bit. You want to avoid wetlands or low areas. Some areas you can't. You can put a crossing in a wetland. It's going to be hard to get permits, and it's going to be a little bit more rigmarole, and it's going to be a lot more robust, but I certainly don't recommend it. You need to know whether it's year-round use. You go out to a day like today where I still got frozen ground and the animals still need to get. Can I use it year-round? Is that something the landowner can manage? Can they plow snow off it? Does it get too icy? When do I need it? And if they're going to need it year-round, it's going to have to be a lot more robust. And most importantly, you don't want to obstruct normal flows. One of the criteria, design criteria, says the channel cross-section in open channel has to exceed the channel cross-section of the existing channel. We'll get into this a little bit, but you can't obstruct normal flows. If your crossing obstructs normal flows, water is going to go where it's going to go, and most likely it's going to go around your crossing, and it's going to erode on the flank. And then you want to avoid seepage, excessive grades, or channel alignment changes. Those are just bad conditions you want to avoid. So I stole this from the presentation last week, and I thought it was pretty good. So this is a creek that was actually destabilized by a poorly installed crossing. I stole that from the 580 presentation. I think it was 2 weeks ago. I thought this is perfect for my presentation. If you look on the photo on the left, that's the downstream photo, and if you look at the photo on the right, it's the upstream photo. And the issue here is that crossing that they're kind of standing and looking down is actually above the bed of the creek. So it's actually kind of functioning as a minor dam. It's going to pond water behind it, which is going to drop the sediment out, and then it's going to force the water over top of that, and then we get an unstable condition below it, which is probably causing some type of heading cutting. So by improperly placing this crossing, you're opening yourselves up to all kinds of future possibilities for failure. So be cognizant of where am I placing it, and making sure that I get below the grade of the stream bank. You look at this photo, this is a concrete crossing. This is precast panels, right? Looks good. I don't do a lot of these myself, maybe a handful of times, but I looked at this. This is an existing condition. What's wrong with this photo? Well, in low flow conditions, which are still carrying the base load, it's above the elevation. So there's no question in my mind that at the other side of this, at some point in time, I'm going to get a sediment deposit, or in some cases, if the water can't pass this because of this crossing and the excessive vegetation, it's going to find its own path, which will most likely take it beyond the protection that you provide at the crossing. So be cognizant about how you place these culverts in the water course. Make sense? It's hard. I'm not getting any of your feedback. So if you have questions, feel free to put them in the chat box. Kelly will ask them to me right away, or unmute yourself and ask me directly. All right, we got some drone photos. I like drone photos because they really kind of spell things out. This is a project out of Gaming County, what I think is pretty well planned. There's a lot of 580. There's some stream bank protection going on here. You've got some rock riprap, you've got some root wads, you've got some rock riprap, you've got some root wads, you've got root wads here. So the technician really has worked on this stream bank, But since I've got a farm here and I've got a farm here, the landowner needs to cross. And what I like about this crossing is even in this sinuosity, in this curvy section of creek, the technician picked possibly the straightest section he could do to install that crossing. And then he installed the crossing well beyond what he considered to be the 10-year storm or the bank full flow. You can see it extends well out, so it's protected. It might not be protected in a flood event, but he took it well outside and he tied it in with that protection. So I don't have a gap in between here. So, and the crossing width mimics the width of the stream, both upstream and downstream from it. Okay. So to me, this looks like a pretty well planned crossing, and it looks like ultimately it'd be a success. And what I mean by a success is where it's around for a while. Last year, in 2018, 2019, we had a lot of severe hydrologic events. We had a lot of practice built, a lot of failures due to conditions. We're getting to the realm where we have to make these practice just a little bit more robust than the 10-year storm, just due to the rate that we get storm events. This is another practice, another typical use of a crossing. What you have here is you've got a grass waterway, nicely netted with an erosion control blanket. The landowner needs to get across to that grass waterway. And instead of going multiple different points, we opted to do the crossing at the end. It's a smaller crossing, and then down below we have a kind of good wetland scrape in wetland enhancement. We actually pulled out some cattails on this and created some open water habitat as a means for a stable outlet. We're also using this crossing as kind of a stable outlet before it gets into this wetland. So this is, folks have tried this before. This is a classic use of it, but this is one way to do it. All right, these next three slides are pretty good, and I like these drone photos because they really tell a pretty decent story. This is a project in Calumet County that we worked on, and this was before we got out there. Okay, so if let me get my laser penner here. All right, if you look at the existing crossing, the landowner's got a big culvert. This is a perennial creek that really should be flowing in this channel, but instead it's so full of sediment, so full of deposition that it's actually left its banks, and it cuts its way out on the right. Downstream from that, we've got significant bank cutting, we've got significant erosion. And what we really realized is we've got a lot of sediment deposition within this creek. And a lot of the reasons for that is because of this culvert's too small. So we'll advance the slide, right? And you can see a little bit more of a close-up. And you can see that we've got multiple braided channels. Again, this is a big sediment deposition here, and it's due to the fact that this culvert's not doing what it's supposed to do. It's too small. So, and this is a case where we said, okay, this culvert crossing, even though it's really working for the landowner, it's not working for what we want to do with the stream bank design. So in this case, what we did is we removed, I take that back. Let me get out of that. Well, in this case, what we did is we physically removed it and we installed the crossing, and we took that crossing well below well beyond the floodplain components of that. Did a lot of stream bank protection and adjacent to that, but that's just not the focus of this presentation. But we realized the culvert crossing, the existing culvert crossing, was probably not the best way to get across to this perennial creek. So we opted for an open flow device. Keep in mind, basic engineering, I'm a technician, I'm not a civil engineer, don't pretend to be one, but basic engineering says if I've got open channel flow, I can pass more water than sticking it through a pipe. And that's what we needed to do in this application, because the pipe, the culvert, was not allowing us to pass flow, which was then slowing the water flow down, which was creating the sediment to drop out. You drop that sediment out in the center of the channel, the creek's still coming, so it's going to find another place to go. A lot of things you're going to need to do. Okay.
Hey, Drew.
Yes.
I think it's for this slide. John added, you also did culvert protection down by the road.
We did do culvert protection down by the road. Absolutely. John, thanks for adding that out. Down by the road, you know, this creek had to go into that culvert underneath the road. So what we did is we armored it. We protected that culvert as it went underneath that town road. But it was a really successful practice because we simply did the proper crossing that should have been in there in the first place. Right. So let's talk
Randy
about.
also asked about the capacity of the downstream culvert.
Well, that's a good point.
What about the downstream culvert capacities? I don't know.
Well, that's a good point. Okay, so we're going through a town road on this location. The downstream capacity is definitely going to pass the 2 or 5 year. And I know John and I evaluated it. It's going to pass them out, but it was another case where we're kind of stuck with what we got. It is a bigger culvert downstream. It's probably 48-inch diameter, but it was a case where we kind of had to deal with what we have. So that's why we did that culvert outlet protection. And if you look on that photo, we did culvert outlet protection, not around the culvert. We actually brought it up about 200 feet and protected it with riprap. So we know when everything passes through there and hits this, not all passing during this peak flood event, I've got some protection as it punches back and slows down. So that was kind of our logic behind it. We do monitor. It's an easy one to look at. So, you know, and John, unless you got something different to add in, it seems to be a fairly robust practice. This was done 2018, 17, and it seems to function pretty decent. Unless I'm missing something, John. Okay. Let's talk about use. All right.
John just added, sorry, Drew, little delayed here. It's still holding up. Landowner still loves it to this day.
That's what we want to hear. Landowner loves our practices. That's perfect. Success. Okay. All right. So use, when you're planning these crossings, you really want to know what you're going to use it for, and not just what you're going to use it for today. What are you going to use it for 10 years from now? Because these practices, once they're installed, you want them to stick around a little bit. You know, we're doing a lot of culvert replacements. You work in Marinette and O'Connell and Brown. There's a lot of culvert replacements because things have changed. Conditions have changed. Use have changed. Resource concerns have changed. So you want to make sure what you're doing it for is going to be into the future. You want to know whether it's equipment versus livestock. Equipment is typically going to be wider. It's going to be based off the equipment needs. Livestock is typically narrower. Standard has some minimum limitations. Livestock, I think it's 6 feet. The point, if you have livestock to get across that creek, you want to get them fast. You don't want them to turn around and have a conversation with a cow behind them. You want to get them through that creek and get to the other side. Equipment, it's got to be wide enough, you know, so that in the middle of the night when you're combine and you're driving home and you're too tired and you're not paying attention, you don't drive off your crossing. Add a little bit of safety in there, make sure the crossing is wide enough for the dumbest driver. That's my logic. Okay. Frequency of use. Is this going to be used every day because it's closest to the farmstead? So I have to be more robust because it's going to be beaten down a little bit, or this is going to be used once or twice a year. Figure that in there. Culverts can be expensive and they can be cheap, but you have to size them for what's crossing them, what you're going to use them for, and how often they're going to be used. Every time you walk across the crossing, or every time you drive across the crossing, you're degrading it just a little bit, right? Time required for cattle movement. Again, we want to get the cattle across, right? We don't want the cattle to sit in the creek and play. Hoof contact zone. This is one that I've always struggled with all my years. Hoof contact zone for the landowner. Hoof contact zone. That's where the animal's feet touch the ground, so to speak. That may include sand, ground limestone, rock screenings, or similar materials. I have always defaulted to having the landowner tell me what they want for the hoof contact zone. I've had landowners say limestone screenings are the greatest things ever. And I've had landowners say limestone screenings are so small they don't come out of the hoofs. I've had landowners say gravel is okay. And then I'll have other landowners say gravel is too sharp. I really bring the landowner into this and say, okay, these are your animals. This is what you're accustomed to. What can we do for hoof contact zone? Keeping in mind, hoof contact zone is kind of a sacrificial material. You know, we're not designing for the hoof contact zone for these for the 10-year storm or low bank flow, but we're designing for the animals. So I specifically asked the landowner on that. If other people have different thoughts on it, I'm all ears. But that's just kind of my practice been, you know, in the last, you know, some odd years I've been doing this. Design criteria for crossings at grade. Equipment ramps 7-to-1 or flatter. I've seen them go 6-to-1. It's okay. Keep in mind when you're driving down a crossing with a, you know, and you're towing something, you might have some issues. Livestock ramps 4-to-1 or flatter. Keep the crossings narrow. 4-to-1 is still kind of steep, especially on a day like today where it's a little slick outside. Biggest thing is to direct the runoff away from running down the crossing. Don't turn the crossing into a lined waterway. It's not designed for that flow. You don't need to create damage on that flow. You don't need it to create any gullying down perpendicular to the culvert. Put the widths per standard. I think minimum width for livestock is 6 feet, and I think it can go up to 25. Equipment crossings, again, discussions with the landowner. You got to fence it, especially with livestock. You're going to have to fence it. Fencings are kind of tricky, right? Because you need to fence it. And you need to keep the animals in there. But fences are also awesome devices to grab debris and flood in flood-prone areas. So when you do your fences, make sure that you have breakaway panels or you've got lift-up floodgates. There's plenty of standard drawings that are available for this, but you have to plan for your fencing to pass those flood events. Otherwise, they're going to grab all this debris and it's going to ruin your crossing. Make sure the stream bed is firm. Again, if it's not firm, make it firm, and I'll show you how to do that. Now, the other thing, another criteria is don't place the crossing downstream of a culvert. All right. If the culvert is squirting out water, that's going to be squirting out at a super high velocity, and it's going to defeat your calculations for open channel flow. So I stay away from culverts or pipes. I don't put an open channel flow next to a pipe. It just doesn't make sense to me. All right.
Drew?
Yeah.
Pete had
Say it, Kelly. I can't.
An addition here that I thought was worth bringing up. He says widening the crossing. Can you hear me now?
Yes.
Okay, so Pete added widening the crossing at the bottom so the trailer hitch or equipment won't drag in a more of a V-type channel.
Yep.
Can cause sedimentation problems because you're slowing down the water. He had one landowner who got stuck in the accumulated sediment. The bottom was stable, but the accumulating sediment due to the lower velocities caused the problem. Well,
so Pete, I'm going to ask you this question. So when you do your crossings, you're not taking it to a narrow point and allowing that thaw wave to pass. Or you're planning on making it level.
Try to do that, but in this case, there is such a high load of sediment in that stream coming from above.
Yes.
That it's still accumulated to such a depth that the landowner got stuck. So, sediment load something to think about. But
yeah, that's a very good point. We don't want to get in that condition. I mean, because if the equipment gets stuck, it's going to tear up everything we did. So the standard is going to say shape everything to the center line and then pass that low flow. But in some cases, we gotta pass that sediment. We can't have this be an unstable condition. Thanks, Pete. That's very sound and good advice. Right. This is a picture. I think this is in Ashland County. I have stolen slides from various presentations, and my coworkers work all over the state, so I begged to borrow. But this is a beautiful crossing, and what I like about this crossing is it's actually blended into an access road that's coming off the farmstead. So you really can't tell where the crossing starts and the access road starts. So most likely, by looking at this photo, the crossing is really from here to here, but it's blended in with this access road. I have no break. So when I do have a flooded event, I've got total containment. I don't have an area, a weaker area for that flood flow to go around. And here the fencing is robust enough that I think it will be able to sustain what we need to do. Here's another view of it looking the other way, and it takes it well up into the crop field. So This is a class example of where you've got a crossing that has been combined with an access road, and it looks like a big crossing, but it's really two different components blended together, and it looks awesome. Okay. All right, design criteria crossings at grade. Ensure that the cross-sectional area of the crossing is equal to or greater than the natural channel crossing cross-sectional area. This is critical, okay? And this should happen anyway. Typically, when you're going to make this crossing, you're going to give it a greater area, but you're going to run a survey through the existing area where you're going to do where you're actually going to plan the crossing. What you plan beyond that has to have a greater cross-sectional area. If it doesn't, you're squeezing that creek tight, you're taking away what used to be there, and that creek is still going to find a place to go, and it's either going to flank you or cut into your crossing or do something that you don't want to plan for it. So you have to ensure that the cross-sectional area of the crossing is equal to or greater than the natural channel crossing cross-sectional area. You do this by taking a survey, plotting out that survey, and then overlaying it with what you're planning on doing. Hey, I'm going to do a crossing that's 12 feet wide with 8-to-1 side slopes. As you come in there, it'll show you, and it'll show you in the design calculations that, yes, you've addressed this component of the standard. To the extent possible, design the top of the forward crossing to follow the contours of the stream bed. Right? That's the best way. Now, again, Pete just brought up that point where you've got that lower V channel, or that lower flow channel, even in this bullet beyond that, that might be a sediment concern. So that might be something to consider if you're in a high sediment producing area. If you're in a forested environment, maybe it's not a major issue. But if you got a high sediment load agricultural area where you've got a lot of erosion, you got to think about it. One of the mistakes that I have made over the years, because I'm a technician and I look at the problem, okay, I focus on that crossing, and what I've tried to force myself to do in my later years in my career is to look at the problem and then backstep and look at it with a wider lens. I focus too much on the individual gully, the individual stream bank, the individual crossing. I have really focused to see, where does this BMP fit within the environment, and what is it affecting downstream and what it's affecting upstream, or what upstream or downstream affects it. Just like Pete had mentioned, that's sediment deposit. Somebody chime in. Okay.
I got a couple questions I'm saving for the end, Drew, but I guess if you can pause,
I'm almost done. I'm almost done with this design, this one, and then we'll go into concrete crossing. So one more. Recess the subgrade of the stream crossing so that the constructed surface of the crossing is at or below the original surface of the stream bed. Have to do it. If you don't do it, you create a minor impoundment that gives you issues with the photos. All right, Kelly, what do you got?
Let's see. Since it's mostly related to what you got going right now, I had a question from Josh. After the rock is placed, is topsoil ever placed back on top and seeded over? Say I have a stream crossing at a park and the trail is used for hiking and small machinery, so having a seeded top would be preferable.
Yes,
or you could keep it as rocks.
No, you know what? You could do that, but again, all your top dressing, it's kind of sacrificial, and that's where you kind of got to use your judgment. For example, let's say you do your crossing and you top dress it with soil, and you put down an erosion control blanket as much as possible, and it's not a wet period. In other words, you've got not a period of high inundation like 2018 and 19, and you put your topsoil down, and you can get some seeding. You have to accept some loss on that one, because people are going to walk on top of it, and two, you're going to put an erosive material within your crossing where you're protecting it. But on the flip side, you're still going to get some protection by that vegetation. So to me, it's kind of a practice that I certainly would try. One of the things that when people work with me, I don't have to get 100% solution. If I get a 50% solution, it's better than nothing, right? So in that case, especially for like a trail in a park setting where you've got other factors in that, it's certainly worth an attempt. Now, if you were going to say, hey, let's build this in September, I'd say you're crazy. You know, you're not going to get anything established. You're late in the year. You're going to put that topsoil down. It's going to end up downstream. But if you were to say and you know, put in all your limitations, say I'm going to build it at the right time of the year. I'm going to seed it at the right time of the year. I'm going to use an erosion control blanket. I'm going to mitigate people walking on it. Yeah, you've got a chance for some success, maybe 100% success, but it's certainly better than no success. So I'm not opposed to trying it, but keep in mind, you still could have a sense for failure. You're going to lose that hoof contact zone during peak floods. You're going to lose that hoof contact zone, and in your operations and maintenance plan, you have to have a plan to replace that or add that in there. Anything else, Kelly?
Yeah, if you want to revisit it, we had a question about when you put your crossing in a waterway. Let me see if I can go back up and read it. About how you keep water from getting backed up, which I'm pretty sure you covered, but if you want to revisit, you know, when we put what you mean by putting them at grade.
You have to figure out where your grass waterway is bottom. In other words, you're going to build that bottom of that grass waterway. You're going to grade it out, put it at your design slopes, design width and side slopes, and then you're going to cut your crossing into that. So if you're going to do a grass waterway and your stone is 12 inches thick and you got a 6-inch layer of gravel on top of that, you're going to go to the bottom of that grass waterway. You're going to cut 1.5 feet out. You're going to strip that out. You're going to put that gravel in there. When you are standing on your crossing, you shouldn't be higher or lower than the grass waterway above and below it. You want a nice surface. You're going to have a little bit, but you certainly don't want to build it up, right? Because you just built yourself a dam. It might not be a dam in the sense where you're going to pound everything back immediately, but you're going to slow that flow enough. And one of the things I try to teach technicians, imagine this thing actually working. In other words, it's full to your design depth. It's going up to your side slopes. And now it hits this little 1-inch layer of rock that's above the surface of the grass waterway. For a moment in time there, it's going to pond back. And if it ponds back, that water's still going to go. So it's going to go out of bank. It's going to flank, and it may go on the outside of your crossing and create, you know, 2 gullies instead of just having 1. So I try to keep it as flush as possible. I think that's my best advice for you. I hope that makes sense.
I do believe, okay, so there's a follow-up question to that. So at a grass waterway crossing, you're still driving through water.
You can during storm events, absolutely, right. But you're driving through that grass. You're driving on you know, on that bed that you've designed for that. So yeah, technically you're driving through water. If you got a 25-year storm going on and you've got that designed for that, and your crossing goes beyond that design depth, you can drive through water, right? And that's the resource concern that we're trying to mitigate. So you don't want to have multiple crossings. You want to keep it down to 1, make it robust, get in there and get out. But yeah, you're driving through water.
Thumbs up on that response, Drew. So I think you got her question for her. That's good.
Okay.
So the other question I have is about permits. I don't know if you want to save that till the end.
Yeah, let's save that to the end, because, you know, that's a tricky one. And quite frankly, there's people in this audience that are going to have better advice than I do. And that's where the strength of, you know, the field staff really come into play. You've got all your different experiences, especially work with DNR and Army Corps. You bring that question up, and if I don't know it, I know somebody else will know it. So, all right, let's talk about concrete crossings for using concrete. I don't do a lot of these. I've done less than 5 or 6 in my career, and my career is, you know, fairly lengthy. But they do have some value. They do have some value, especially if the landowner is going to do it. They're robust. But use a concrete crossing only when the foundation of the stream crossing has adequate bearing strength. I'm going to put a concrete slab on a creek. I don't want to put it soft. Right? Where do I get that bearing strength? You can actually pull that out of the USDA soil survey. That information will be in there. You need to make sure that will handle your concrete. You're going to place a minimum of 5-inch concrete, and you're going to construct the slab on a minimum of 1-inch thick gravel base, and make sure the foundation is accessible. Precast concrete panels may be used in lieu of cast-in-place concrete slab. What I mean by precast concrete panels, cattle slats that you would see in a freestyle barn, in a manure storage. You can actually pull those out and use those. I'm more inclined to use precast concrete cattle slats, which come in dimensions of 4 by 8 by 10 or by 12. I'm more inclined to use those than poured in place concrete, because usually where I'm going to do the concrete it's probably in an area where it's difficult to get a concrete truck, but I certainly can truck out a couple of panels and set them in place. I also like the fact that panels have the ability to move and adjust, which is good and bad, because if they move too much, then they act as an obstruction, but at least they're not cracking. So this is a photo of the excavation for a concrete crossing. You look at this and you say, well, this looks like a good solid, clay material. So should be robust. You form it out, you put your reinforcing steel in there, and you pour your concrete. This is another one. This is a longer one where they took it well beyond. This is a nice, it provides a decent, robust surface, and it gets to be a little bit fairly pricey. Travis, I know I'm encroaching on my time a little bit, so I will speed this up. Design criteria, rock crossings. Okay, rock crossings is typically what we do. When you use a geotextile, you use it when you have a soft or unstable subgrade. You're always going to use non-woven type 2 class 4 is most used. I never in my career use woven geotextile because I don't want to do the percent fines test below it. Make sure you go to Wisconsin Construction Spec 13 for the details on the types of geotextiles. And more importantly, if you're not comfortable with that specification, go to the guide for use in the Engineering Field Handbook, Chapter 17. There's a guide for use for this specification, and it really does an awesome job explaining what woven geotextiles are, what non-woven geotextiles are, and what the tables really apply to. If you got questions on that, you got plenty of DATCAP staff out there that can step you through that. You're going to cover the geotextile with excavated bed with rock as shown in Table 2. Table 2 is fairly straightforward. I pull this right out of the standard. If you got soft foundations, you got 18 inches or 8 inches underlain with gravel. If you got firm foundations, you've got 8 inches. Yeah. Here's a photo. You're going to roll this stuff out, and then you're going to push this material on top of it. Same thing here. So it's fairly an easy practice. Most of the crossings I do that I get involved in uses some type of geotextile. And then here's the top dressing and that's showing the hoof contact zone. Final product. Geotextile really gives it a lot of strength. It has a little bit of, when you got a little bit of seepage, it's pretty decent. So here's a big statement, and this is right out of the standard. Okay. So now we're getting into design. We shift gears from planning. We really want to know, how do I design this, right? You need to design the rock forward stream crossing base material. In other words, the stuff that's going to resist that design flow, not the with contact zone. It's got to be stable for the 10-year storm or bank full flow, whichever is less. In other words, I'm going to figure out what that 10-year storm is, whether I use EFH2, TR55, USGS method. I'm going to figure out what that is. I'm going to put that quantity of water in my cross section, and I'll show you the spreadsheet to do this, and I will see what elevation that 10-year storm is, or by visual means, I'm going to determine what my bank full elevation is. Then I'm going to use an equation called Manning's equation that will help me get my velocity. I will tell you my default is the 10-year storm because I think it's more conservative. I'm very aware of climate change. I had a couple of practices fail, especially last year. John, you can raise your hand. I'm more conscientious of maybe our practices are not as robust as I think, especially just the way things are changing. So I've decided that I'm going to be more conservative in my design. So in a lot of cases, I automatically will drop to the 10-year storm event. What this chart is, and I may be doing a little bit backwards, this is the stone size as it resists velocity. So you're going to use Manning's equation, which I'll step through in a little bit. That will help determine your velocity. And then your velocity equates a stone size. What this stone size, it says D50 in inches. What does D50 mean? D50 says it's the middle size stone in a given pile. So if you got a pile with 6-inch stones and 1-inch stones, your D50 size would be 3 inches. You're always designing for that median stone style, and it's basically based off weight. So you'll have to run a gradation. We run a gradation where you've got big stones, a lot of medium-sized stones, and a few small stones. You mix them all together, you got a decent gradation. when you're doing these rock crossings, you have to design for a gradation, and you're designing for the middle-sized stone within that pile. And then once you design it, you got to make sure you can get it. So then you go to the quarry, you do a gradation check, you make it, you measure the stones, you stick it in the nomograph, and you figure out whether you can get it from that quarry, which is a whole nother training session, which we're going to have in the future, but it's a skill that you have to have. So if you need help determining a gradation, please contact me or contact your DACAP or NRCS area office staff. We know how to do it, and it's a skill that you have to do it, to make a gradation. Okay, let's continue on.
Drew, this might be a good time for one of the questions we got here. It's about the geotextile.
Yep.
Do you ever have the contractor bury or dig in the geo edges like on the standard drawing?
The book answer is yes, but honestly, no, I don't. Not often. Not often. I think it's important on the upstream side for sagging, to be honest with you. But in most cases, it's rolled out, laid out, and that's just a technician talking. That's just what it is. I'm picky about overlaps, obviously, big time, and I'm very picky about the product. I'm so picky on getting the right product. I ask for the manufacturer's test data before they buy it, and then I compare it to what's in WCS 13. So what they're buying is right. So, the apparent opening size and the elongation at failure, all these minimum test requirements, you actually meet them. So I'm more picky on the product, but I dig in the upstream and downstream, upstream ends specifically, but on the sides, can't say I have. Pete, what's your advice on that? You still there with me, Pete? All right.
Oh, sorry, I was typing a comment, Drew, when I missed what you said.
So do you bury the geotextile on the sides? I do it on the on the top ends, but do you do it on the sides? I haven't done it on the sides. I suppose you have to, but I don't.
Yeah, here, step up, catch it and try to roll it, but not always on the side.
Yeah, that's kind of that's what I thought.
I mean, what's going to catch it there on the sides like that?
Exactly. Exactly.
Especially if you have large enough rock, in my opinion.
Yeah.
With a smaller rock, I might be more concerned about it.
That's good. Okay, so again, the standard says you got to design for the Q10 or bank full flow. Travis, and I'm going to punch through this, man. I know I'm encroaching on your time by 3 minutes. Here is a list of bank full flow indicators. I'm not going to read them to you, but I will tell you where this information is. This information is found in Wisconsin Supplements in Chapter 16. It will specifically, it's for stream bank design, but that's where I pull this information from. Make sure you're getting familiar where the resources are. The stuff is right online. You go to NRCS website, Wisconsin Supplements. This will tell you what your bank full stage indicators are. Again, you have to design for the 10-year storm or the bank full flow, whichever is less. Here's 7 ways to determine what the bank full stage is. Once we get all that, we're designing by the velocity method. So we use Manning's equation, the most favorite equation that we all love and follow. Manning's equation. It's the only equation that I actually can remember without looking at my prompts. 1.49 divided by the hydraulic radius to the 2/3 to the slopes of the 1/2. All right. You run that equation with your Manning's end value, you will get velocity in feet per second. I take that velocity in feet per second to that table 2. It will tell me what my D50 size stone will be. That then sets my gradation. Now, Manning's roughness coefficient, in layman's terms, it's how smooth or how rough things are, and they equate that to a number. You could go Google, you could Google Manning's end values, and there'll be a list of Manning's end values a mile long. In a stream bank, you can either calculate it, and this is pulled out of natural channel flow for stream bank design. You can actually calculate it, here's your basic end value starting at in earth is 0.020. And then you add these modifying factors and you figure your degree of meandering. I don't necessarily use this for a crossing. What I use is I use the formula method and I use the Manning's end value for the stone that I want to use. Keep in mind when you're designing and you're using stone, you want to make sure you can get the stone. I know, for example, in Northeast Wisconsin, I can get D50 size stone 6 inches almost everywhere. My coworker, Ryan Glassmaker, told me that last summer it was hard to get D50 size 6-inch stone in Southeast Wisconsin because they were crushing it all down to gravel. So I like to look at availability of stone, and then I use that Manning's end value. I know that getting D50 size of 12 or more, which I don't ever use, but I know I can pull that out of the Valdez quarry. So figure out where your stone is coming from and figure out what sizes that you have available. You don't want to truck it 3 counties away because then your crossing is going to be ridiculous expensive. And then use that Manning's end value. You're going to stick that into the Manning's equation. That will set your depth. Manning's equation, simple for open channel flow. You pull it off the NRCS website. It's fairly straightforward. Your inputs are your side slopes, and that's you're coming down and coming down. Your bottom width, which should be equal to or greater than your creek, your depth, and your slope in feet per feet, based off your survey of the water surface profile. This will size your crossing for you. You can also use this program. This is Natural Channel Flow. This is an awesome program where you're going to enter in your cross-sectional distance, your elevation, your Manning's end value, your upstream water surface elevation, your downstream water surface elevation, which will get slope, which is filling in this Manning's equation, and then your water surface elevation within that channel. So you can move that up and down until you get that capacity of that 10-year storm. So you're going to raise this elevation in your cross-section up until that 10-year storm is fit into this. And I realize I'm going fast, but what I recommend you do is when you get to this point, you call your DACAP and you call your NRCS assistants, or more importantly, you ask people within your counties. Again, I look at this list, a lot of experienced people out here. There's a lot of help out here. Don't try to figure it out yourself. This is a standard practice we've been doing for years. NRCS has a whole list of different standard drawings that will fit your application. They're 400 series drawings. I took this right off the website. So you want to look for what you might be using and then see what these standard drawings fit. There's very little need to change these. They're fairly straightforward. Depending upon your condition, there's a lot of them out there, so I'm not going to go through each of them. I'm just going to show you 4 examples. They're basically fill in the blank. They're not very hard to do. And operation to maintenance. And I know I'm pushing my time, but I talked a little bit faster, more than I wanted to. Crossings, you want to inspect after heavy rains. You want to inspect for any type of hydrologic events because you're going to wash materials away. Remove that deposited vegetation and sediment and replace the hoof contact zone. Again, when you get to the point where you're designing these, it's worth a 15-minute phone call to your area office staff, and they will step you through these spreadsheets. We just don't have time to do that today. So I know I went over my time, Travis, so I do apologize for that. Kelly, do you have any further questions?
I do. Going back to when you started your concrete crossing, you mentioned bearing capacity. Someone asked if we needed on-site soil tests for bearing capacity.
No, I wouldn't do that. You know what? I think you can use book values for bearing capacity. Now, if this is going to be a very robust crossing, then maybe you want to consider it. But most of our applications, I look at it this way. So if you're wrong with your bearing capacity and this thing fails, it's not that big of a deal. All right, we can fix it. We can replace it. These are not, 365-day use crossings in most cases. So in this case, I think you're going to be able to use book values based off your soil type, and I think you're going to be okay. You're going to take cracking. It's going to crack as concrete does, but it's probably not going to affect what your intent of the crossing is going to be. What else you got, Kelly?
I don't know if you said it before or not, Drew, but I was just going to add to that, confirming that the soil type that's in Web Soil Survey is what you have on site as far as I go.
Yeah, especially you in Southwest Wisconsin. Absolutely. You
Yeah.
know, your stuff, you know.
I got one other question for you before we hit the permit question, which we can decide if we have time for. Is there any compaction for your crushed rock, which I believe is the surfacing material we've been talking about, correct?
Yep. That's the hoof contact zone. If your crushed rocks should be compacted, and you're going to be, you know, you're going to use the weight of the equipment itself. Usually, that's enough. I've seen vibratory rollers. Out there, I've seen that used on gravel a bit too. It depends upon how thick your stone is. If you're going to go with a robust thickness of 18 inches, you're going to have to compact it more. If it's a lesser thickness, maybe your existing equipment is going to provide that for you. Again, that's your judgment. That's when you're on site. You need to make sure that you're flush with the ground upstream and downstream of it when you're done with the practice. So you want to compact it to that point. I know that's not solid guidance, but these are practices that you got to use your smarts, and I know you have them. So you got to use your best judgment and modify accordingly.
I'm going to pose the permit question, Drew, and we'll see how much time you want to spend on it.
Sure.
But it is specific to Ford, so I didn't want to wait till after Travis's. I wanted to cover it now, at least ask now. The person asked if Ford crossings were still exempt from permit or not. And I'll throw up my memory first, I guess, here.
Yeah, good.
There's a list of permit exemptions or permit requirements that you need to meet to be exempt from a permit out there. If I can find it here, I'll throw it into the chat maybe a little bit later. But I know I've seen those before. They exist for most permits when you don't need a permit. If you have anything to add to that, or if anybody else does, or if we want to save that till the end to see if we have time.
Let's save it to the end. I don't know if anybody else has got better advice. I'm all ears, man.
I'll see what I can gather while Travis is.
Yeah. If Wes is on there, I know you're Wes. Wes is a permit expert. Travis, you probably know as much as I know or more. So, but with that, I'll turn it over to my coworker, Travis. Again, I apologize for taking into your time. I was just so excited because his practice is so cool, and I think everybody needs to know it.
Well, it's good stuff, Drew. It's good stuff. Don't worry about it.
All right. I am going to stop sharing, and it is all you, my friend.
All right. All right. Hopefully you can see that. My name, like you said, my name is Travis Buckley. I'm the DATCAP area engineer covering the northeast part of the state. And yeah, we're going to roll right into this. So yeah, Drew kind of got you all warmed up with crossings, but we're going to specifically now talk about culverts. All right. What I'm going to go through here, we're going to do a quick crash course in culvert hydraulics. And then we're going to talk about a little deeper into the 578 standard, specifically on the culvert criteria. We're going to touch briefly on some design tool stuff, and then we'll get into a little bit of installation stuff to keep in mind. So again, this is going to be pretty basic. There's a lot of people that do a lot of culvert stuff, and there's folks out there that devote their careers to culverts. So by no means are we going to touch on everything in this session, but we're going to hopefully get some basics. All right. So first up, a quick introduction to culvert hydraulics. So first of all, I guess, what is a culvert? Well, culvert is basically a conduit that conveys water from one side of something to another. So pretty basic. Obviously, culverts are everywhere. I mean, take notice on your way home from work today. There's culverts under roads, trails, walkways, driveways. I mean, culverts are extremely common. All right, culvert shapes. Kind of the big ones, circular. We've all seen those. Elliptical, a little less common. I used them a lot when I was doing a lot of fish passage work when I was working up in Oconto County. They worked really nice for that, especially if you have streams with little lower banks, they fit into a lot of sites really nice. So we got to using a lot of them. Kind of the arch is also pretty common, especially for aquatic organism passage. And then, we can also have a square or rectangle. Usually you see these in their concrete form. So as far as material, obviously the most common one is probably metal, galvanized metal. It's pretty cheap. We can also do coated metal. Again, we seeing more and more of this. The coated helps prevent rusting and kind of get some added life, longevity to the metal culverts, especially if they're going to be in submerged or kind of wet areas. Might be worth the investment. Obviously that's a little more expensive. Plastic culverts are also pretty common. Again, plastic is really good for longevity. It's not going to rust or anything like that. Obviously the trade-off is maybe some loading or strength issues. And then concrete, again, you see these quite a bit. Obviously fairly expensive compared to plastic and metal. And then corrugated and smooth walled is also something you're going to run into as well. All right, culvert inlet types. This is basically the entrance of your culvert. You can have wing walls, which I know we've all seen. Just the straight projecting is obviously very common. But this matters, when we talk about capacity and some of the design stuff, that entrance to that pipe has an effect on the hydraulics. So it does matter what that inlet type is. And we'll talk a little bit about that when we get into more of the design stuff, but just be aware that there's obviously several options out there. All right. So culvert flow, basically we can break this down into two forms. We have flow under inlet control and flow under outlet control. The first one, inlet control, this is where our discharge and our capacity in our culvert is controlled at the entrance. So, basically the entrance is acting like an orifice, and the barrel of our culvert is not flowing full and has not become pressure flow. So you can see in the picture there, let me see if I can get my pointer up here. Yeah. So you can see, in this picture here, we have our entrance is submerged. The inlet of this pipe is acting like an orifice and is letting less water in than what the full barrel would be able to convey. So inlet control, big things on inlet control is the headwater depth, and obviously that entrance type that we just talked about, inlet entrance geometry. So, all right, the other one is outlet control. Outlet control has kind of three different forms that it can take. The first one is full flow for the entire length of the culvert. So that would be like this one here, full flow. Or we can have full flow for part of the culvert length, like this picture here. Towards the end, we start losing that full flow. This could be example of maybe a little steeper culvert or something. And then we have open flow for the entire culvert. So again, this is outlet control versus inlet control. All right, so now I want to get into the 578 standard, which is the one that Drew was kind of talking about before, but we're going to talk specifically about the culvert criteria. So the 578 design capacity for culverts follows table 1. This is right out of the standard. And it obviously depends on your type of crossing. So if you have, a forest, farm field, basically think something that's not going to have the need for emergency vehicles. Now we're looking at the 2-year storm or bank full flow if that exceeds kind of the 2 year, if the 2 year exceeds your bank flow, then to use full bank flow. So again, think out in the middle of nowhere. Once we get into farm driveways or non-public roads, then we're looking at the 10 year. And again, this is, in case we had to get emergency vehicles, we're being a little more conservative to hopefully prevent failure in a safety situation. And then public roads, we're looking at the 25-year storm. So again, these are kind of these are new culvert capacity requirements. Some other criteria in 578, there's no culverts in places where you're going to have large amounts of sediment coming down your channel or large amounts of woody material. And again, this is to prevent plugging risk and failure potential. So, if you have a site that, is historically been passing a lot of woody material, probably not a good idea to put a culvert there. Also, if you have a stream that has a grade greater than 6%, again, also probably not a good place for a culvert, because you're going to have, extremely high velocities in that channel. So, 6% is not really very common, especially in Northeast Wisconsin where I work. You're lucky if you can get 1%, let alone 6%. So not something we've run into, but it is out there. The other criteria that's in 578 is at least one of your culverts has to be 6 inches below the stream bed. I know this is challenging. 6 inches is quite a bit, especially when you're talking, maybe a 24-inch or 12-inch pipe. The option there is, to meet the standard, you need to get 6 inches bedded, and then, maybe you add another pipe that's more at stream bottom for water conveyance to cover that 6 inches. So again, that 6 inches is for, the goal there is organism passage to make sure we don't have perch conditions or anything like that. So, but be aware of that. And then obviously making sure your culvert is adequate length. When you're planning a new crossing, make sure you plan for, in addition to your top width, also plan for, the side slopes on that crossing, and make sure your culvert extends, beyond, where those side slopes are going to come down. All right, the other thing that I wanted to talk about here is this concept of flow bypass. The standard allows you to basically you can make up some capacity with a flow bypass. So if, say your bank full flow or something, or even, your 2 or 10 year storm, is a culvert alone is just not going to have the capacity you need. You can add, additional flow capacity for non-public roads that is. So basically, you have your culvert, and then you have a channel that, as your culvert flow is exceeded, that water has a place to go. So in this, we have our culvert crossing, but we have this bypass channel that any flow that exceeds this culvert has a place to go. And I would encourage this thinking on every culvert crossing, especially new ones you're putting in, just from a, emergency, kind of failure analysis standpoint. It's good to know, hey, if this culvert gets overwhelmed, where's that water going to go? And can it go somewhere where it's not going to cause a problem? And this, obviously, climate change is a big topic right now, and it can be challenging to, maybe build extra design resiliency with just a culvert. So that's where these bypass channels are kind of nice, where you can add some capacity to your project and, get a little conservative built in. So, in this case, this is just being driven across. So, I mean, this is a very gentle, flat, obviously something that the landowner with machinery is not gonna have an issue with. And then this is rocked for erosion resistance. So this is designed like a rock line waterway type situation. So, but yeah, just something to keep in mind when you're doing culvert crossings. Keep that what if scenario in mind, and maybe incorporate something like this. I get a little cringy, planning for overtopping right over my culvert, right over my crossing, just because if you would have a failure and lose that and have erosion or washout, now you're losing your pipe. In this case, if this erodes or washes, we're just losing some rock, and that's a little easier and cheaper to fix, if this culvert can stay in place. So just something to keep in mind. All right, now we're going to talk briefly about some design tools. There's a lot of design tools out there for culverts. Use what you're comfortable with. There's a ton out there. I'm gonna talk about a couple. These aren't necessarily the best or greatest, just what I've used. The 578 standard specifically says design your culvert in a manner that's consistent with sound engineering and adequate for its use. So that's obviously pretty general, pretty basic. So whatever works for you and is going to get you good data, by all means, do it. Again, design capacity. So if you're doing a new culvert, you're looking at this table 1 for the 578 standard, and the design tools we're going to talk about. Culvert design is such that you don't plug in your design, you don't figure out your design capacity and it spits out a culvert size. You need to compare what you come up with for your design capacity to your culvert design. So it's kind of a, this is a whole nother course. Drew talked a lot about it earlier, so you should have a pretty good sense on it. But figuring out your design capacity of what you need and then designing the culvert is kind of the process on that. The one that I'm going to kind of focus on today is the NRCS design spreadsheet. And the only reason I'm using this one is it's readily available. This is right on the Wisconsin NRCS website under spreadsheets. So it's available to everyone. It's easy to access, and it gets the job done for a lot of cases here. And this spreadsheet can be used for new culverts as well as evaluating existing culverts. If you had an existing culvert, obviously you're plugging in, the information and the data that's out on site to figure out the capacity of that pipe. If you're doing a new one, again, you're putting in your planned data, and then comparing that to your stream capacity that you already figured out to figure out what you need for a pipe. So, but again, this spreadsheet is readily available, and we'll go through it briefly here. But before we look at plugging in some numbers, just be aware of the limitations of this spreadsheet. I think that's important to know if it's going to fit your project or not. The NRCS design spreadsheet is specific to a single circular culvert. So if you're doing multiple barrels or, elliptical or something like that, maybe this isn't the right design tool, or you might have to, keep that in mind when you're using this. It also doesn't account for bends or slope changes. Again, not real common. Usually we're doing a straight section of pipe. It also assumes that you don't have any fill. So this is assuming you know, a clean empty pipe. So that gets interesting when we talk about having one of our culverts bedded 6 inches. You know, the spreadsheet is not going to account for that. So keep that in mind, that that could be an important factor when you're doing your analysis. It also doesn't analyze for road overtopping. So this spreadsheet is not going to know where your road is in relation to flow or anything like that. So there are other tools out there that can help with that, but just be aware that it's not gonna do that for you. All right, so this is the spreadsheet. Pretty simple input wise. You're just going to go through these green boxes. You know, the first one is your headwater upstream, the elevation. So basically it's this elevation of this blue line here. A lot of times this is approximated depending on your design storm that you're looking at. Your culvert inlet elevation. So this is the elevation of the bottom of your pipe on the upstream or the inlet end. And then obviously your culvert diameter. So whatever size you're looking at in inches. And then your length of pipe. And then your culvert outlet elevation. And then the elevation of the line. So pretty straightforward. There's not a lot of inputs. Again, if you're evaluating an existing culvert, you would get this information from the field and then enter that. If you're doing a new culvert, you would be picking this information, and you know, it's going to be an iterative process. You know, you might have to play with culvert diameter and things like that to get the capacity that you need for your project. All right, the other thing you need to enter is your culvert material. We already talked about kind of what are some of the common ones. This spreadsheet allows you to do concrete, corrugated metal, plastic, corrugated plastic, and then, you know, kind of a smooth HDP, the black stuff, and PVC. So a lot of options. You know, you can do concrete, metal, or plastic, which is, you know, that's pretty much all you're going to need. And then we talked about this as well, your culvert inlet type. This spreadsheet allows you to do head walls, kind of the projecting or the mitered. In my experience, you know, the most common is projecting. You know, we do a fair amount of head walls, you know, sometimes, but obviously projecting is my experience the most common, but you would pick that. And then just to plug some numbers into this. So in my fake scenario here, our culvert invert elevation. So again, that's this point right here. We're calling that 100. Our headwater upstream, we got 3 feet of water. So we're up to 103. I'm choosing, I got a 24-inch diameter culvert that's 40 feet long. And basically I got a foot of pitch on that pipe. So down here, we're at 99. And in this case, I'm going to assume that, you know, basically the water, this tailwater elevation is equal to the end of this pipe. So assuming no tailwater on this pipe. And you can see when you hit compute, it's giving me a capacity of 18.6 CFS, and it's inlet controlled, right? Which makes sense since we already talked about that. You know, we have, you know, our pipe is not quite flowing full, and the inlet of our pipe is acting like an orifice. All right, so the other scenario is same pipe, so we have same elevations, but now I wanted to say, all right, now the outlet of my pipe is now submerged. Now we got 3 feet of water on the downstream end of my pipe. So the inlet submerged, the outlet is submerged, and now we got a capacity of 13.3 CFS. So our capacity dropped because, and you know, we're under an outlet control flow scenario. So just kind of, again, just kind of shows the different flow conditions and how that affects it. All right, the other one I want to briefly mention, just because I use it a fair amount, is HydroFlow. And this is an extension within Civil 3D. I'm running 2018 Civil 3D, so I don't know how this, or if this is even still in some of the newer versions, 2022 or things like that. But it is in 2018. Basically, you go under Analyze, Design, and then there's Launch Express, and it brings in extension. And it's kind of a cool extension that allows you to do culverts. There's also stuff in here for weirs, channels, and inlets. So it provides some nice hydraulics design tools. But the culvert one, the thing that's kind of nice about this one, it's not as user friendly because it has quite a bit more inputs. It allows you to do different culvert shapes. This program does allow elliptical. It does take into account multiple barrels. I know it's kind of hard to see, but you can change the number of barrels, so you can figure out 2 culverts at once as opposed to NRCS one. The other nice thing about this program is you put in your embankment information. So you put in your top elevation and your side slopes. So this program will figure out road overtopping, which is kind of nice. So some of the limitations of the NRCS spreadsheet, this program gets around. So you can do different than circular. You can do more than 1 barrel. You can figure out road overtopping and things like that. So just be aware of it. We don't have time to get nitty gritty into this, but hopefully it's still out there in the newer versions of Civil 3D. I mean, maybe somebody that's running it and is familiar with this can speak to that, but it is in 2018. All right, the other thing I wanted to touch on real quick is culvert installation. So just a few concepts to keep in mind if you're doing a culvert inspection on a project. The first one is the foundation. So this is where you're going to put the culvert. We want to make sure we have a firm, stable foundation to put that pipe on. We don't want to have a situation where we set our pipe down and it starts sinking. That's bad. We also want to make sure we have that firm, stable foundation the entire length of the pipe. So we also want to avoid, things like frozen soil, organic matter, large rocks. Pretty straightforward, should be pretty common sense. This applies to a lot of our practices as well. But if we don't have a good foundation, we can always place some good foundation material to get that in place. So again, we don't want to put a culvert on goo. The other thing I just wanted to mention, a lot of times you're not going to be able to get a culvert that's maybe long enough for your application. So in that case, you're going to have to band it together. This is, something the contractor is going to deal with, but just work with your pipe supplier and figure this out. This is for corrugated metal. Concrete or plastic is going to have some different banding or connections necessarily, but this is a common one for metal. This can be, I've heard some contractors cuss at these, especially doing, we were banding some elliptical pipes one time, and that was a real pain in the ass, to be frank. But all right, culvert backfill. So this is key for success of a new culvert. We want to make sure we have well-graded granular material if possible. Again, we want to avoid frozen material, organic matter, large rocks. That's just not good fill material. And then compact. Cannot say that enough. We want to compact all the way around this pipe. So we want to try to get good compaction around the haunches. Usually that's done by hand with like a 2x4. You want to make sure you're filling evenly on both sides and along the entire length of the pipe. So you don't want big globs of fill going down your pipe and trying to compact. So we try to get 6 to 8 inch lifts that are uniform down your pipe, and then again compact. That's going to be huge for longevity and success of that pipe. And then as far as fill over top, again, that's going to depend on what your crossing use is on that project. I was always taught, shoot for at least 1 foot of cover or half your pipe diameter. So if this is a 36-inch pipe, you want to try to get 1.5 feet. Right or wrong, that's kind of what I've used in my career. It seems like it has worked pretty well, but kind of try to get at least 1 foot of material. Again, what the load is on this culvert is going to have an impact on that, as well as just how the elevations work. I mean, obviously you don't want a giant hump over your culvert if they're going to be trying to, you might not have a happy landowner. So it's going to be somewhat project dependent and material dependent. All right, just some other considerations. Obviously, keep aquatic organisms in mind. We want to make sure we have, we don't want to disrupt ecology when we're doing stream crossings as best we can. So that's where making sure we get culverts bedded good, getting substrate into the pipe is also good for aquatic organisms. So
sorry to interrupt, Travis.
Yeah,
I got a question. I think it's better to address. It went in your last slide.
Okay.
Dan Sloop asked, can you specify what you mean by granular material?
Granular material. So we're talking well-graded sand, gravel is what I mean by granular. Something you want something that's gonna compact. So that's where the well-graded comes in. Well-graded means you have a variety of particle size. So, sugar sand or washed stone, 2-inch washed stone would be an example of poorly graded, and that would not be what we're looking for. So we want a variety of size material that's going to lock together nice and going to compact nice. So. All right, alignment is also important. You need to kind of think stream hydraulics when you're doing your culverts. I've replaced a lot of culverts, road crossings that, they went, religiously perpendicular to the road, but the stream didn't necessarily go perpendicular to the road. So replacing that culvert, maybe it's a good idea to, add a little length to the culvert and put it at a little bit of an angle. You're going to improve hydraulic efficiency as well as, potentially organism passage as well. So we'll keep alignment in mind. Also keep, kind of your upstream and downstream conditions. Are you going to do you have an erosion concern downstream, with your culvert? Are you going to have a sediment deposition upstream? Things like that are important to kind of keep in mind when you're doing a culvert crossing. And we talked about this a little bit. You're loading, what is that culvert going to be used for crossing wise? Are you going to have heavy machinery? Are you going to have foot traffic? All that plays into, what your fill materials, what your fill height's going to be, what your culvert material is going to be, all that stuff. As far as permits, that's a dark rabbit hole that we don't really have a ton of time to get into. My say would just be, culverts are permitted. So talk to, your DNR waterway permit folks and, work with them. If you're replacing a culvert or putting in a new culvert, talk to DNR and get them involved. They're going to be the experts on what's required or not. I mean, there are exemptions out there but they would be the experts on that. So, all right, that's all I got. So I think we got pretty much right on time here, but yeah, if there's any questions or anything, let me know.
I do have some for you, Travis. Let me just see. Is there a rule of thumb of when we want to use a culvert versus a ford crossing?
My stance would be go forward first. Just ford crossings are, obviously a lot of landowners like culverts because they don't have to drive through water, but ford crossings, are you can get way more capacity flow wise through a ford crossing than you'll ever get through a culvert. So that there's a lot of, there's a lot more forgiveness in a ford crossing in terms of capacity. So I always try to get a ford crossing first and then go for a culvert. But a lot of times landowners, like culverts for obvious reason.
All right, I got a few different things I'm just going to state out loud, and you can add anything if you want to, but I had some experienced people put some stuff in the chat for us.
Okay.
For your calculations, when you were working at the spreadsheet, I just wanted to point out the headwater elevation is where it's overtopping the road or whatever's above your culvert. It's not necessarily directly above your culvert. I think you even showed the example, Travis, where you were directing water around a side overflow channel.
Yep.
So just worth mentioning, it's not necessarily just what you survey directly over top of your culvert.
Yep. And that's a good point. Yeah, your headwater is going to be, if you do have that bypass channel, that's going to come into play too. So that's a good point.
Yep. Thanks to Doug for that one. And then I think it was Brady and Seth, both one for 2020 CAD and one for 2021 CAD. That program that you showed briefly is available in both 2020 and 2021 AutoCAD.
All right, yeah,
calculations.
That's good to know. It's good to know too, and maybe that's something we could do. That's something we could maybe get into more detail on another session too, if that's something people have interest in. But I personally use it quite a bit, and personally like it. So it's good to hear that it is in the newer versions of Civil 3D. So it's good.
We just got a yes in the chat, so I'm thinking that's used to, or that's in response to what you're talking about, Travis. So maybe that is something we want to look into having a future training for.
Yep, that's something.
I like it too, for the record. It's nice. I like it. One of the other things in the chat, just mentioning when you're talking about cover over the pipe, I think is when this came up, that HDPE pipes will want to float when they are submerged.
Yep. Yeah, that's definitely something to keep in mind too. That for those that haven't done a lot of culverts, yes, flotation is a concern and something you need to look at. So there's there's calculations out there for that. So yeah, if that's, again, that'd be a talk to your engineering contact if that's a concern, but definitely keep that in mind. That's a good point.
That is all I saw from during your presentation. If I missed anything, guys, please resubmit. I did look a little bit for exemptions for permits. Other than culvert replacements being exempt, I did not find any current exemption list for like ford crossings like we might talked about earlier. So definitely be in contact with your DNR contacts for those permits to make sure we're using the most current policy for the DNR. Unless somebody has anything to add to that.
Yeah, that's my best advice, is talk to DNR, because you don't want to, I'd hate for you to assume and then run into an issue. So.
Right. And I know I've had a permanent exemption list for ford crossings before, but I'm wondering if it's outdated. That happens more frequently than I'd like to admit.
Kelly, Travis, this is Seth with Dane County. I'm wondering if I could jump in on that permit thing.
Yeah, go ahead, Seth.
Go ahead.
typically there are wetland exemptions for things like agricultural access roads and crossings. So some of that may be exempt, but again, talk to your DNR water management specialist, because there are things that get in the way. Crossings through navigable streams do require permits. So if you're doing a crossing in a waterway where there's no stream, no wetland, you know, no permit required. But if you get into wetlands or streams, you may or may not be exempt.
Thanks for adding that, Seth. Not seeing any other questions in the chat. I do have a comment related to our ford versus culvert crossing. You can just read out loud here quick. Jonathan Grove in Racine County, it looks like. In the southeast, he's always tried talking to the landowner into the ford crossing first, just like Travis had said. If a culvert or culverts are the last resort, keep in mind, if you are in a cropland setting, there's a risk of corn stalks flowing into the channel, and anything smaller than an 18-inch pipe will plug. So some would argue don't go any smaller than 24 inches. So something to keep in mind. It's a very good point.
That's a very good point. And that's why it's good that you're chiming in with your experiences. We just don't ever know everything. So Jonathan and Seth, I do appreciate you jumping in on this and providing your insight. Anybody else? These are good comments. All right, Travis, are we good? As I'm good.
Yeah, I guess thanks again for taking some time. It was good discussion, and hopefully you found some value in it. So.
Yeah, we can do it in face-to-face in the future. Kelly, thanks for handling the questions, and again, thanks for your input. You guys you know what you're doing, and your input is valuable. Thanks again.